Assalamualaikum. My name is Eman Hari, and today I'm going to start the video of our final year project for Harvard. Let explain to you a bit the Unity layout. I'm going to start with the main scene that we have designed. That is the introduction of our game. The game is going to start with this screen. Let's start. This is the play game option. I'm going to start the game. So the music and the audio listener function, the other function starts. So offers us three options: easy, medium, and hard. And the user, as soon as the user sets the difficulty level, the code automatically starts. As soon as the game starts, see, we have offered the user choice of the difficulty level, and based on menu, this is a basic options menu that every game has to offer. The music on and off toggle button, as you can see, and the quality high low button that is for invisibility of people who don't have better gaming systems. The toggle music function, that is a basic function that takes in the boolean input from the user and operates so. And then there is this change quality function for optimization based on the user choice that takes in false and true function. The reset function is a basic function that can reset our choices back to normal if we have changed any choices. Moving on, there is a help option. The help is a basic panel which offers us the controls. We can customize this as well. For more help, we have offered our user tutorial as well, so they can engage in the game from the level of a beginner to a basic player to a pro player as well. Option, if we go over the code, all the basic operations that our main menu is offering: the quit game, reset, load game, start game. So these are all basic operations. So load game takes use of the player prefabs that I mentioned before. So for Android, it will save all the player prefabs in the root directory of the game, and for the PC, it will save it in the directory that you have decided for the game. And basically, what Unity does is that it uses the player prefabs to create instances of each user based on what point they were at in the game. So whenever the user chooses the difficulty, if we have anything saved, we can load the game from there on. And this is the basic load game function that Unity has inbuilt for us. So as you see, Unity has already begun the game.
Now we're moving on to the player movement module of Pearl Harbor. This character in itself is a rigid body which has been imported from the Unity asset store, and around this rigid body is a mesh collider. This mesh collider is used when this body collides with any object on this canvas in this environment, and with every interaction the body will behave differently and there will be a different outcome. To start modeling, we started with a main camera that has basic movements that the human eye, if we look towards our game physics module, we try to model it to as close to reality as we can. If we look at the human eye, if limiting the camera, we have clamped the vertical rotation to 180 degrees, and there is no clamp on the right or the left movement of the camera. This camera is independent of our current frame rate. If to make it independent, we have introduced a time delta variable that is initiated every time the frame rate is switched in our game. By multiplying time delta with every x variable and y variable, move x and move y in our camera scales, it makes it frame independent. Next, moving on to the basic movements, that I press W, if I press S, A or D, these are all the keycodes that Unity will use to detect these motions. So for W and S, the vertical axis is used. Every time I press W, the vertical axis is added by +1. Every time I press S, it subtracts -1. Similarly, for A and D, the horizontal axis is used, as you can see, and the horizontal movements that any game has. The next movement is running. So for running, I'll give you a background on what kind of speeds the user will have. This user has a basic walk speed that is around 10 floats. Then the user has the run speed and the crouch speed. So for this movement, the key code is shift. So as I'm walking using W and I press shift, the user starts walking. Now the walk speed is shifted to run speed, and the run speed is around 14 floats. Now the next movement that I have designed is the crouch. The crouch, so if the user is in the crouch position, the backend Unity will detect the collider height and increase it with 1 on pressing of C again. Now the height of the rigid body has increased. Now if I want to crouch again, it will subtract 1 from the rigid body and make it go back to the crouch position. In the crouch position, the user can walk as well. Now the walk speed has been shifted to the crouch speed. Basic movements that any game requires. The next movement is the game is a jump movement. For the jump movement, we use the method called is grounded. So right now my player is grounded. Step offset and the slope offset are altered. So the step or the slope offset and the step offset come in play when I jump, and it takes a look at how much higher can I go. So in this case, if we realistically use the game physics module, we see that gravity is used in real life as well. When we jump off from the floor, we cannot just float off. So for this player, we have grounded this player using the gravity module that Unity provides. And as soon as I return to the ground, now I am in the landing stage. When I'm in the launch state, the velocity keeps on increasing, and as soon as I reach the peak, the velocity starts to decrease. And when it decreases, the velocity now changes into. So these were the basic and the most essential movements that are required in our game. And so if you see, this is the player input. The camera function has been designed over here. The jump, the crouch function that is needed for stepping, as you can see, and for sprinting, for landing, everything.
Hello, Assalamu alaikum. This is Hamdan Khanzada, and I'm the member of this group. And our project is we basically my part is basically focusing on the train and the environment setup and the features of the game. So while explaining to the train, there are many things, including it that there are many assets in this game which we have imported through. Unity asset store, and these are the list of the assets. As you can see that there's barrel, there are vehicles, there are military camps and gates, etc. So there are many things. So basically, this is a detailed train review which we have made by myself. I have made it, and as you can see that we can drag and drop and do changes in it if you want to increase its height, its width, and at the right side you can see at the panel there is many options. Okay, so we can change the position, the x-axis, y-axis, and scale it accordingly to our point and increase its size. Okay, move the distance and lightning statistics, whatever we like to do. Okay, so we have basically made it through ourselves. For example, this is a fence, and now see, as you can see that we can basically increase the length of the fence and the width of the width of this fence. So as you can see that we can basically build the train however we please to do. Okay, so as this is a military game and we are basically focusing on a war, so this is designed actually as a base camp of our enemy, which our person have to exploit it and had to do some attacks, okay, and complete some missions. So these are the list of the basically things, the bands we have. So you can see just we can just increase the tires, the length of the tires, and just make it in a fashion that it's according to us. And secondly, on these all object we have used mesh, and which basically is a collider. Okay, so by setting anything on the a function of you can say an object, that mesh is required. Okay, for example, we have allotted a mesh on a vehicle. When our persons come near to the vehicle, it's give a messages that please open the door or sit on the vehicle. Okay, this is an example of a mesh. Okay, so they work as in collider. Okay, when our object, our player has its own collider, okay, and the object has its own collider, and when the colliders are in the same stats, okay, in the same exact position, the options are enabled. Okay, so this is the code which we are being basically it's the code of the player. This is the missions where we are going to describe it. The first mission we have is the main plane, the main FPS plane, the plane cam. Okay, and here is the basically the all the terrain is designed consisted of this. Okay, now this is the basically the main train, and the camp is basically a part of this train. Okay, that has been designed individually. Here's our main camera. So as far as you can see that this is giving a complete whereabout an idea of the train, that where it is located. So in each and every thing of this train, just like if we click on this plant, okay, so we can basically analyze and determine its position by ourselves. We can completely autonomously design it by ourselves without any external force. Now these are the weapons which we are being using the prefurbs. As you can see that we have a list of prefurbs here, and we can just drag and drop them. These prefurbs are basically downloaded through many stores.
Assalamu alaikum. This is Aga Moiz, and this is a technical introduction to our FYP project, which is Pearl Harbor. In this short span of time, now you can see that this version is an Android version of the game, and I am trying my best just so I would get to these buttons later. Just this, I would try to explain the Windows version at this particular point. This is a collider coming into play. My player has a collider, and the object whatever object which is placed on this particular terrain has a collider, a mesh collider, or a box collider, or a lean collider. Whenever two objects come into contact with each other, they collide. Obviously, their colliders detect this particular moment, and a text is generated on the UI screen to pick up that particular object. This is how I picked up the knife over here. Now, the visible ray would be cast towards the way I am facing, like my camera is facing at this particular moment. That ray depends upon the range it has given. For instance, so in this particular point, I was holding a knife. That is why I had to move closer to the dummy in order to come in contact with it. Now, as you can see that my ray has been casted on the gun, and it has given me an option to pick it up. Now I am firing it out. It is what it's basically casts a ray in the direction, particularly speaking, I am facing, or my camera is facing at that particular moment. So this is a ray, like as I mentioned, raycast is being applied on our drag body, rigid body, our character damage control, our FPS player, and enemy AI as well. Let me just Okay, so coming to the game again, this now I have come in contact with a car. Now the car control on its own is another story. A car has an acceleration. This is what now game physics module coming in. I'm aiming at the object. This is now NPC won't come in contact with me as long as I am not in its range. As soon as I came in its range, you can see him attacking at me. The health bar is declining as long as I'm getting damage over here. You can see that both of the bots are firing at me, and my health is deteriorating. Each time I am aiming and putting in the mouse left key button, the total ammo is being subtracted, minus ammo minus. Let's just discuss that particular aspect in a bit. Let's just pause it. Yeah, if I talk about my damage and my weapon behavior script, there is a script applied to each separate weapon. For instance, AK-47 has a different script and has a different functionality. Shotgun has a different functionality. Weapon object has a different. This is your MOUI object as well, which I was told to implement in my 70% presentation. As you can see that, and obviously has a lesser range. Raycast is being applied on each of these guns. I would come at later stages. It would also give an option to pick up a number of weapons. You can see the muzzle effect come into the play as well. Each time the bot is getting hit, it is accessing my stats and I am accessing his stats. Now you can see that as soon as my health went to 0, I would be again starting the same round I died at that. Coming to the bots, now you can see that I'm picking up the ammo and going to the boss stage. Nav Mesh is being applied on this particular area. Nav Mesh is another technology which is being used in this particular project. Nav Mesh, if you obviously bake the Nav Mesh, giving in ranges to your NCP players, obviously your own player, which they can exceed or which they cannot exceed. As soon as my player come in contact and comes in the range of that NCP, it faces towards the camera I am posting at, and it starts attacking at me. This is done via scripting once again. Moving to the base, you can see that the bot won't attack me as long as I don't come in contact with or come in the range of that bot, particularly speaking. This is once again game gravity, all of the modules coming into the play. They cannot attack me as long as I am not in their range. Coming to another important module of the time, as the time is very limited, converting all of this game into Android module. As you can see that there are several buttons used. What I did was I took input based on the touch screen input, like the amount of time I applied input on my touch screen, that was the input taken on the update function of this particular speaking player controller key. So Android had its own player controller and the Windows function had its own player controller. So what we do is we basically download an SDK and a JDK for Unity. So by putting in the values of SDK and JDK, you go to the build-in settings, and then you build in the project for the Android module. You design these buttons using once again the UI key buttons. You import each time you go to the UI. This is my control freak, which I have used in this particular point. Control freak is another functionality which Unity allows you. It aids in designing several controls for the Android module on its own. It automatically maps those position based on the input screen.